looking at day 2 for absolute value functions and their graphs. We are going to be graphing an absolute value function by performing operations on the parent function. So again, yesterday we talked a lot about the parent function. We talked about the basic absolute value of x. And then our focus yesterday was on stretching, compressing, and reflecting. So we only made changes to the slope or to the direction the graph opened, which was up or down. Now we're going to extend those changes one step further. We're going to start moving the graph left or right. We are also going to move the graph up or down. This type of transformation is known as a translation. So this type of movement up or down and left or right is known as a translation. It is a shift horizontally or vertically. Again, not changing the overall shape or orientation of the graph. We will still have a V-shaped graph, even though we're moving the vertex. We'll still have a V-shaped graph, even though we are moving the vertex. So in order to graph the following two functions, we need to do two things. First, we need to identify our vertex. So the vertex is translated based on the k value. So the first graph has a k value of 2. So what that does is translate my graph up 2. Which means my vertex is 0, 2. So now instead of plotting and starting at 0, 0, I am starting at 0, 2. The a value is 1. So that means my graph goes up 1, right 1, up 1, right 1, up 1, right 1. Remember that if it goes up and right, it also goes up and left because the graph is symmetric about the vertex. So that means the graph is symmetric about x equals 0 because the axis of symmetry is always through h. So yesterday we talked about the domain. This domain is still all reals because every x value has a y. The range, however, yesterday was y greater than or equal to 0. Well, since this graph is positioned up 2 units, my range is now y greater than or equal to 2. That could also be written as a bracket from 2 to infinity. So we've identified our vertex, discussed the transformations, and we know the domain and range. Okay, let's look at y equals the absolute value of x minus 3. So the negative 3 following the absolute value will translate my graph down 3 units. That makes my vertex 0, -3 now. Once again, the A value is 1, so it's going to go up 1, right 1. And anything it goes up and to the right, it goes up and to the left. Domain is once again all reals. My range, however, instead of being up, has now gone down. So the range has expanded. It's now -3 to infinity. Is this a function? Yes. Is this function 1-to-1? No. So it's a function because it passes the vertical line test. It is not 1-to-1 because it fails the horizontal line test. Okay, now let's look at the effects of H on a graph. So we're going to identify what the H value does. So in this first equation, we have y equals the absolute value of x plus 3. So it's important to recall from yesterday, and it's up above on that screen a little bit, that the equation is y equals a absolute value of x minus h plus k. So in our equation, since this is a positive, that really means this is like the absolute value of x minus a -3. So it's really like a double negative, which means my graph is moving to the left 3 units, not the right. My graph moves 3 units to the left because it's really like a negative in there. Which means my vertex is -3, 0. And again, you could confirm that if you plugged in -3, you get 0. The A value is once again 1, so my slope is 1/1. The axis of symmetry has now changed. The graph is no longer symmetric about the y-axis, or x equals 0. The graph is now symmetric through the line x equals -3. So my axis of symmetry is x equals -3. It is always equal to the h value of the vertex. The domain is all reals, and the range is y greater than or equal to 0. Okay, let's look at y equals the absolute value of x minus 4. So this graph, since the equation is x minus, that means that my vertex has moved to the right 4 units. So my vertex is a positive 4, 0. And again, if I made my table using the breaking point, 4, 0 would be in the middle. So you'd look at values less than 4 and values greater than 4. So 3 minus 4 is negative 1. Absolute value is 1. 5 minus 4 is 1. 6 minus 4 is 2. 2 minus 4 is negative 2. Absolute value is 2. So again, we could plot points by making a table. And all I did was simply plug those points back into the original function. And once again, I can see my domain is all reals. And my range is y greater than or equal to 0. The graph will be symmetric through x equals 4. So that means my axis of symmetry is x equals 4. So what happens when I start to move my graph, not only just left to right, but up and down, and eventually we're also going to start changing the slope. So now we have changes on both H and K. So the vertex is 2, 3. Which means my graph has moved right 2 and up 3. So this purple graph over here, that's the parent function. So all I did was put the parent function on my graph so you could see what these changes are doing from the original parent function. So we're going right 2 units and up 3. The A value is still 1. So again, if I were to make that table, we'd be looking at 0, 1, 2, 3, and 4. At 0, we'd get 2. 2 plus 3 is 5. At 1, you'd get negative 1, but the opposite value is 1. 1 plus 3 is 4. And 3 minus 2 is 1, plus 3 is 4. 4 minus 2 is 2, plus 3 is 5. So again, I can see that slope of up 1, right 1 happening, even if I create the table. Domain is always all reals, because those are like the free points when I ask you for the domain of an absolute value. Do not miss that. The range in this case has to do with the movement up. So now my range is y greater than or equal to 3. Spencer, I'll change the homework if I keep watching you do that. Okay, graph the following functions without making a table. So the vertex is negative 1 inside. So it's a positive 1 on my vertex. The plus 3 tells me up 3. And my A value is once again 1. So my slope is 1 over 1 for x values greater than or equal to 1. And it will be negative 1 over 1 for x values less than or equal to 1. We don't really care which one includes the equal, because at 1 the slope is really kind of like changing. So that vertex 1, 3 tells me my graph went up 3 and right 1. And since my slope is 1 over 1, I connect my lines. Domain is all reals. And range is y greater than or equal to 3. It does not stay that simple. You can see in this example here, we've now changed our slope. So the slope has changed, the vertex has changed, so my graph is changing. The vertex is -1, -2. The slope is now -3. So that -3 and that -1, -2 tells me my graph went left 1, down 2, stretched by 3, and it's reflected over the x. So it's left, down, stretched, and reflected. I do ask you for the words. I want to know, what do all of those numbers mean? So let's start with the vertex. It's -1, -2. The -3 tells me from my vertex, I'm going down 3 and to the right 1 unit. We know that the graph is symmetric about the h value, which is -1. So that means if my graph goes down 3 and right 1 from the vertex, it goes down 3 and left 1 as well. So the domain remains all reals. The range, however, is flipped. So previously the y values were greater. Now my y values are less than or equal to that k value. So my y values are less than or equal to -2. Or you could say they go from -infinity to -2. Remember, if you're going to use the infinities, the negative is always on the left, the positive is always on the right. I could not write -2 to -infinity. That's illogical and unaccepted. Okay, let's graph the following once again. The a value is 2. The vertex is the opposite of the inside. So -2, -3. That means that this graph is left 2, down 3, and stretched by 2. My axis of symmetry is x equals -2. So that means my graph is symmetric about that yellow line. There's my vertex. And then my slope is up 2, right 1, up 2, right 1, up 2, right 1, so on and so forth. But because it's symmetric, that means if this point is 1, 2, 3, 4 units to the right, there's also a point 1, 2, 3, 4 units to the left. Just like a line, there are arrows at the top of the absolute value, indicating it continues in both directions forever. My domain is always all reals, and my range in this case is all values, including -3, up to infinity. Looking at all of the examples from today, is there anything I said that maybe you're like, nope, still don't agree, or I don't know how you got that, or could you go back to that? I know this is a lot of information. Some of it's very new for you. So are there any questions for me about the A, the H, the K, how we get the vertex, etc.? Yep. Sure. So for stretching and compressing, it all has to do with the A value. So if our A value, and that's right here in our formula, if my A value is greater than 1, then the graph is going to be stretched and it's going to become taller or more narrow. If the A value is less than 1 but greater than 0, the graph is going to be wider. So yesterday, a big part of our homework was looking at those two different types. So a narrow graph might look like this. That would have an A value greater than 1. A compressed graph is going to be more outward like that, where my vertex and my original sorry, I hit eraser. Come on. The parent function is going to live in here. So the outer function is an A value between 0 and 1, and the inner function is an A value greater than 1. The positive or negative tell me whether it opens up or opens down. It does not affect the stretch or compress. And again, you can plot points by making a table for any one of these. Okay? That's a summary. It's not in your notes. If you want to take a picture of it, you are more than welcome to. That very next page in that packet is your homework for today. That page and the page from yesterday do need uploaded by Monday at like 7:30 a.m. Some of you said you got an alert today. I apologize for that. I had made the change to the lesson and to the assignment, but Fusion with the app doesn't always correlate those updates. So like I also got the alert on my iPad, even though I made the changes way back on Tuesday. So again, sorry if you got an alert. Nothing was due today. It is not due till Monday morning, as if you had homework over the weekend.